Hi everyone, welcome back. Today we are going to solve a problem of elementary structural analysis which was asked in question number 4A in the May 2014 exam setting. It asks us to calculate the member force in U1, U2, L1, U2 and L2, U3. So let's quickly see how we can do in STAAD Pro. I have already loaded a STAAD Pro in metric unit. So the first thing that I'm gonna do is enter the required node. So for L1, the node will be 000. For L2, it will be 600. For L3, it will be 1200. For U1, it will be 050. For U2, it will be 6 and 2.5. So I like to open the front view. It makes our job easier. And then turn on the node numbers by right click, labels, go to node numbers, and also click the beam numbers. It won't hurt. Apply. Okay. And then for creating the lines for the truss member, just input which nodes connect to which node to create a line. So I will choose one connects with two connects with three, one connects with four, and I'll just minimize this screen. Four connects with five, five connects with three, one connects with five, and five connects with two. So these are just the lines that are in our truss structure. We need to assign the properties to them. For doing that, go to properties, click prismatic, and then you can choose anything you like because for calculation of the member force, the section properties won't matter. I'll just choose a rectangular section, 0.4 meter by 0.2 meter. Material, I'll leave it as concrete because, as I said, it won't matter for finding the member forces. Add, close, and then click assign to the view, assign, assign. So the member properties are assigned. And then go to specification, click beam, click truss, click add, and click assign to view. Assign, assign. So what this command does is it releases moment from the end of a member because in truss structure we should have only axial force that should be either tension or compression. So moments at the end should be released and then go to support, create, pinned, add, create, and STAAD Pro does not have a default option to choose a roller support. So there is a workaround for that. Click fixed but and release all the forces except FY because that's the only direction where roller support provides the reaction. Add. Click on the pin support, click on the node, click assign. Click on the roller support, click on the node required, click assign. And let's see which force we need to apply in which node. We need to apply 72 kilonewton force going in horizontal direction at U1 and 60 kilonewton going in vertical direction at L2. So for doing that, go to loading, click load case detail, click add, choose date, add, close, go to load case, add, click nodal load. So 72 kilonewton was in horizontal direction, click add, and 60 kilonewton was in downward vertical direction. So make sure you assign minus 60 kilonewton and also make sure you delete the force in the x direction. Add, close. So this load need to be assigned at node number 4. You can just click assign to edit list. Type the name of the node, assign. You should see the force diagram over here. Similarly, click minus 60 kilonewton load and click your node number, which is 2. Click assign, and that's done. Then go to analysis button, click define commands, click add, close, and then just press the run button. It asks if you want to save your structure, just press save and then go to post-processing mode. Don't worry about these warnings. They are there because of the moment release, which is common in the truss structure. Select your load case, apply. Okay. We just want to see the beam forces. Go to beam results. So you can see here the moment about jet axis is 0. That's what we want because in truss structure we don't have any moment. Similarly, shear force should also be 0. That's correct. So our modeling was correct. And force in x direction, that's what we want. So the diagram is too rough. Click scale, click apply immediately. So we need to increase the scale for the axial force. Apply. Okay. So the sign convention for the axial force diagram is the tensile force are represented by red color and compressive force they are represented by green color. And if you want to see the values, go to annotate beam results, axial force, annotate, close. So the forces are shown in the diagram, and if your beam number and node number is making you difficult to see your answers, just uncheck this button now, apply. Okay. And still, if you want a clearer diagram, go to scale, click load and result, click just outline over here and click apply. Okay, so that's your answer. So our question was asking for finding forces in U1, U2. So that's 78 kilonewton. It was asking for L1, U2. That's again 78 kilonewton. It was asking for L2, L3, and that's minus 144 kilonewton. And as I already said, the red colors are the tensile force and the green color are the compressive force. So that's all for today. Thank you, everyone.